Okay, today guys, we're looking at the applications of matrices. Now, matrices are used quite often in business and in transport and in a whole range of work areas. So quite often we'll see them used to model route networks. So if you're looking at bus, train, plane networks, social networks, and a whole different range of networks. What we'll do first of all is we'll have a look at route networks. So the way matrices are used is as a tool for helping organise and deal with data. Now, when you're talking about travel between different cities or different towns with a range of destinations, it can become quite complicated. Now, if you've got a small number of them, it's not too hard and it's not too bad. But when you start to get a larger number of them, it becomes quite difficult organising and collecting all that information and looking at all the different alternative routes that you could take. Now, what we're going to do is we're going to take a look at a relatively simple type of route matrix, and this first example is where we've got 3 cities. So the scenario is we've got a small airline service that operates out of 3 cities. So we've got Atlanta, Boston and Charlotte. So they use a limited number of airplanes, and the planner, the service planner, needs to keep track of all the possible trips connecting the 3 cities. Okay. Now, we've got direct 1 stopover and 2 stopover trips. All right. Now, 1 stopover trip means that you start at one city, say Atlanta, make 1 stop, say at Boston, and then continue on to your final destination city, either Atlanta or Charlotte. Okay, so that's your 1 stopover trip. Now, the easiest way to set these out is to put them into a diagram. So this diagram that we have here shows the routes between the 3 cities. So the arrow illustrates the route in that direction. So you can see here, we can start out at Atlanta, go through to Boston, and also there's a route from Boston to Atlanta. All right. Now there's no direct route between Atlanta and Charlotte. All right. So if you want to go to Charlotte, you have to go via Boston and then get a connecting flight onto Charlotte. Same for Charlotte to Atlanta. All right, that's the way this route diagram works. And it's really important when you're drawing your route diagrams to make sure that you have your arrows on there to show the directions of that route. Now, we're going to create a matrix that represents the routes between these cities. Okay, so we need 3 rows and 3 columns, because each row and each column represents each of the 3 cities. So for each cell in the matrix, we'll place a 1 to indicate that there is 1 route between the city in the row and column for that cell. So for example, if you have a look, there's 1 route between Atlanta and Boston. Okay, so we can go from Atlanta to Boston. That's 1 route. Okay, from Atlanta to Atlanta, there's nothing, and from Atlanta to Charlotte, it's not. There's no one route there. Okay. Now, that 1 designates that we have 1 route from Atlanta to Boston. So if we were to look at, say, Boston to Atlanta, we can go, well, yes, there's 1 route from Boston to Atlanta, so we'd have a 1 in there. Then if we were to go Boston to Boston, no, there's no route from Boston to Boston. But there is 1 from Boston to Charlotte, isn't there? So we can go 1 from Boston to Charlotte. Then if we were going Charlotte to Atlanta, no, there's no 1 route from there. But there's 1 from Charlotte to Boston, and there's none from Charlotte to Charlotte. Okay, so if we were to complete that matrix, this is the way it would look. Okay, so we have the zeros indicating that there's no route between those 2 cities, and the 1s indicating that there is 1 route between the 2 cities. All right. Now these are for direct roots. Okay. Important to remember that. That's a direct root. Now, what we're going to do is look at how we can use these matrices if we were to start looking at one stopover routes to different cities. Now, let's have a look at this one. So, what we need to do is first produce a matrix with all the one stopover routes between the three cities. Okay. Now, we've started this one. So there's a one stopover route between Atlanta and Atlanta because you can go from Atlanta to Boston to Atlanta. So that's one stopover. Yeah. So from Atlanta to Atlanta, you do actually have a stopover. But if you fly from Atlanta to Boston, there's no stopover, is it? Because it's just a direct flight. Okay. Then from Atlanta to Charlotte, do we have a stopover? Yes, we stop over in Boston and then fly on to Charlotte. Okay. So based on our diagram, we're going to complete this table, and the way we would do it is we would do it like this, and we'd say, right, we've got our from Boston to Atlanta, there's no stopovers, but from Boston to Boston, there's two. Now, think about that. If you think from Atlanta to Boston is a direct route, from Boston to Charlotte is a direct route. So we've got a 2 there because you can go from Boston to Atlanta back to Boston, or you can go from Boston to Charlotte back to Boston. That's why we've got the 2 in here for our Boston one. And from Charlotte to Atlanta, yes, we've got one stopover, which is in Boston. And from Charlotte to Charlotte, yes, we've got a stopover because you can fly Charlotte, Boston, Charlotte. All right, so we've completed that. Now, this is where we can start to use your class pad. So if you have a look at your original matrix, okay, and enter it into A in your calculator, and we will look at how to calculate those and put them into your class pad, and you'll need to have a look at my next video to see how we do this, and we'll enter them from there. Then what we can do is we can square this matrix. Okay. Now, don't worry about the details about putting this in yet. Just have a look at this. Once we've gone through this, we'll go through actually how to create your matrix in your class pad. All right, so this is our first matrix. Okay. Then we want to square it. So if we square it, we look at it and we go, oh, okay, we've got our matrix for our stopovers. All right, so the first matrix, A, that's our direct route matrix, wasn't it? Okay, so this matrix is for the direct routes between each of the cities. When we square it, we end up with our one stopover matrix between the cities. And see how that works? Now, what we're going to do is we're going to have a look and see what would happen if we take this a little bit further. So now, if you wanted to write the matrix that represents how many routes there are with one stopover, all we have to do is square our original direct route matrix. Okay. So, what would we do to write a matrix that represents the number of routes with 2 stopovers? Okay, that's one of the questions we're going to look at. And then how would we calculate a matrix that represents at most 2 stopovers? Now, the key words here are at most 2 stopovers. I'm going to show you how to do that. All right, so if we squared our original route matrix, we end up with our matrix showing all of the route calculations for one stopover. If we were to cube our original direct route matrix, we would find out what our matrix would look like showing 2 stopovers. And if we want to find out what a matrix would look like with the information that gives us at most 2 stopovers, we add all of those 3 matrices together. Okay, so we're going to continue on and have a look at that. Now, this one is a little bit bigger. This is a 6-city matrix. Now, this one is quite a little bit more involved, okay? So we need to be aware, number one, of our arrows. So here, from, what have we got? We've got LA, Los Angeles, to, I think it's Pittsburgh. So it's a direct route. There's no return route from Pittsburgh to LA. Same with LA to Atlanta. There's no direct route from LA to Atlanta because we need to look at the direction of these arrows. Okay, so it's just one way from LA to Pittsburgh, one way from Atlanta to LA. Between Pittsburgh and LA, it's two ways. Between Pittsburgh and Boston, it's two ways. Between Boston and Charlotte, it's two ways. Between between Boston and Charlotte, it's one way, and between Charlotte and Pittsburgh, it's one way. Between Charlotte and Miami, it's two ways, and between Atlanta and Miami, it's two ways. Okay. Now, when you're doing these, drawing these diagrams, it's really, really important, guys, that you remember to make sure you show all of your directions using your arrows. Okay, now we're going to have a look at this table and say, right, what are the direct routes between cities? Okay, so let's look first. Between Boston and Boston, is there any direct route between Boston and Boston? No. Okay, it's just you'd have to have a stopover somewhere to come back to Boston. Is there a direct route from Boston to Pittsburgh? Yes, we'd put a 1 in there. Boston to Charlotte? Yes, there's 1 in there. Boston to Miami? No. Boston to Atlanta? No. Boston to LA? No. Okay. So what about Pittsburgh to Boston? Yes, we can go Pittsburgh to Boston. There's a direct route there. Pittsburgh to Pittsburgh? No, there's no direct route from Pittsburgh to Pittsburgh. What about to Charlotte? Now, have a look. Don't let this confuse you. This arrow shows that it's only one way from Charlotte to Pittsburgh. So no, there is no direct route from Pittsburgh to Charlotte. If you wanted to go to Charlotte from Pittsburgh, you would either have to go through, we'd have to go through Boston to Charlotte, or you'd have to go Atlanta, Miami, Charlotte. All right, so there's no direct route. Then what about Pittsburgh to Miami? No, there's nothing, no direct route there. Pittsburgh to Atlanta there is, and Pittsburgh to LA, again, one-way arrow, no, we can't do it. Charlotte to Boston, can we do that? No, one-way arrow, isn't it? All right. Charlotte to Pittsburgh, yes, we can do that one. Charlotte to Charlotte, no. Charlotte to Miami, we can do that. Charlotte to Atlanta, there's no direct route there. And Charlotte to LA, no. All right, so let's go through and fill that in. All right, that's all of our direct routes. That's our matrix or table representing all our direct routes between the different cities. All right, what we need to do is determine the matrix that represents all of the routes with one stopover. So what are we going to do? We're going to take our direct route matrix and we're going to square it. And then if we're looking for a matrix that represents at most one stopover, what do we need to do? We need to take our original matrix and add it to the one that has one stopover in it, so the one we've squared. Okay, so it's like a plus a squared, if that makes sense. Okay, and that gives us the information we need to determine how many, or what our route matrix looks like, to determine how, at most one stopover between each of these cities.